In 2017, astronomers discovered an odd-looking object flying through the solar system. This peculiar visitor, named Oumuamua, made its closest approach to the Sun a month before appearing on our radars. By then, it was already speeding away from our solar system on a journey through the cosmos. Its appearance sparked widespread curiosity and interest, especially because it was the first known interstellar object to visit our solar system. The object's mysterious acceleration near the Sun even led a Harvard astronomer to speculate that it might be an alien spaceship. But now astronomers have found an explanation for the behavior of the interstellar visitor. So why was Oumuamua accelerating unusually when it passed close to the Sun? Did it really have any link to alien civilizations? Finally, and most importantly, how will this study unravel the mysteries of the celestial object's origin? Oumuamua caught the attention of astronomers because it had some remarkable characteristics. Firstly, it had an unusual shape, taking on the form of a long, skinny cigar, measuring up to 400 meters in length. No other asteroid or comet in the solar system had ever been observed with this shape before. Secondly, it was spinning like a bottle on its side while orbiting the Sun, another unique trait not seen in other asteroids or comets. Since it was the first known interstellar visitor, astronomers named it Oumuamua, which means a messenger from afar arriving first in Hawaiian. It came from the direction of Vega, one of the brightest stars in the night sky, lying 25 light-years away. Oumuamua's speed was much faster than predicted by the laws of classical mechanics, and its behavior could not be fully explained by gravity alone. Additionally, the object did not seem to contain ice or emit gases like a typical comet. Even the solar energy it experienced could not account for its unusual acceleration, leading to speculation that it was experiencing a non-gravitational force. However, the cause of this force remained unknown. In response to this enigma, researchers began proposing various origin theories. Among these, the most fascinating theory was that Oumuamua was an alien spacecraft designed to capture the force of sunlight using a light sail. Harvard scientists suggested that it was a thin disk manufactured by an advanced alien civilization to travel across the Milky Way. While the results of this theory matched the available data, the idea that Oumuamua was associated with an alien civilization was difficult to accept for many. As a result, other more natural explanations were proposed, which were easier to digest and comprehend. When a comet approaches the Sun within a few astronomical units, solar heating causes the release of gases and dust from its surface, a process known as cometary outgassing. This is typically what creates the coma and tail observed around a comet. As gases escape from the surface, they exert pressure on the comet, providing an additional source of acceleration. This can be likened to how exhaust gases provide a push to a rocket. But the problem is that this phenomenon partially explains the acceleration observed in Oumuamua, and the outgassing it experienced was different from what is observed in regular comets. In 2020, astronomers proposed that the object's acceleration could be attributed to the sublimation of molecular hydrogen. Sublimation is a process whereby a solid substance transitions directly into its gaseous form without passing through a liquid phase. However, a complicating factor is that molecular hydrogen neither emits nor reflects light, making it extremely challenging to detect using standard spectrographic techniques. This means that even if the interstellar visitor was outgassing molecular hydrogen, it would have been impossible to observe it. Things got even more complicated when a counter-study showed that it was highly unlikely for Oumuamua to be a molecular hydrogen iceberg, as frigid conditions required for the formation of such icebergs did not exist. This left the question of how it could contain hydrogen under such unfavorable conditions. Moreover, if hydrogen was present, how could it be sublimating to provide the observed acceleration? These were some of the mysteries surrounding Oumuamua that researchers were working hard to solve. Astronomers revisited the available data to gain a better understanding of the anomalous behavior of Oumuamua. Surprisingly, they discovered a straightforward explanation that had previously eluded them. The answer lies in the phenomenon of irradiation. Ionizing radiation can split water molecules contained in an object, producing molecular hydrogen. It is possible that something similar is happening with this celestial object. In the model proposed by researchers, it is assumed that Oumuamua began its journey as an icy planetesimal. While traveling through interstellar space, it was irradiated at low temperatures by cosmic rays, which warmed it up during its passage through the solar system. Experiments have shown that when solar rays warm up ice, it changes from an amorphous structure to a crystal structure, forcing hydrogen gas bubbles to be ejected. This process could explain the sublimation of molecular hydrogen from Oumuamua and the observed acceleration. The researchers' model proposes that Oumuamua's acceleration is due to the ejection of hydrogen bubbles, caused by the crystallization of its ice as it passed close to the Sun. According to the results, most of the hydrogen produced from in situ ice processing remains trapped within the water matrix until it is heated to temperatures ranging from 15 to 140 Kelvin. For Oumuamua, these temperatures can be reached between 50 and 250 centimeters below the surface, provided the rock has a low conductivity profile. However, for higher thermal conductivity, the required temperatures are reached down to roughly 8 meters, as shown in this figure from the research paper. While comets commonly experience outgassing phenomena, the associated acceleration effects are almost negligible for comets several miles across. However, because Oumuamua was very small, molecular outgassing could impart enough force to result in significant acceleration. So, this is one of the best natural explanations that explain the behavior of the first interstellar visitor. But this may not be the final word. Astrophysicist Avi Loeb, who proposed that Oumuamua was an alien technology, has a different view regarding its surface temperature, and a paper has been submitted that discusses the same. Oumuamua is now far away and traveling at high speed, making it impossible to get a closer look. As of now, we can only rely on the data we already have, or perhaps in the future, when we may have the opportunity to observe other objects showing similar acceleration without a coma or tail. More exotic theories may emerge to explain Oumuamua's journey and origin. Recently, astronomers made a groundbreaking discovery in astrophysics. They found traces of the first stars that lit up the universe, something that scientists had been hunting for several decades. If you missed this episode, be sure to catch up on this exciting discovery.